Okay, so today we'll be looking into shift registers, and this is an alternative approach. So what I've done here is I'll be explaining the waveforms, okay, as well. So with that, you'll be able to understand in a much better way as to how these shift registers do function. So initially, that you have to understand is the basic shift register function. So how a shift register works. Now that all of you have um, you know, are exposed to what is SIPO and PIPO, PISO and SISO, which is nothing but your parallel in, parallel out, serial in, parallel out, parallel in, serial out, and serial in, serial out. So these configurations, I think all of you are very much aware, right? So here we have serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So these are the major bifurcations. Along with that, we also have something called bidirectional shift registers. So bidirectional, normally we see the data which is moving from left hand side to the right hand side, from the input side to the output side, but we do not see data moving the other way around, which means from the output to the input, right? So those kind of registers, they come under something called bidirectional shift registers. Okay. A register is a digital circuit with basic functions. What are its basic functions? Two basic functions. Number one, storage of information, and number two, the movement of information from one point to another. The storage capacity of a register is the total number of bits it can retain. Now, what is a flip-flop? Can someone unmute and respond? What's a flip-flop? What is a flip-flop?
So it's a sequential circuit which holds data.
Okay, how much of data can it hold?
1 bit.
1 bit. So is 1 bit sufficient for us?
No, sir.
Not sufficient, right? So you are now seeing um, data which is going in GBs, right? So which means this 1 bit of data is really not going to help us in any way. So we have to enhance the storage of, uh, we have to enhance the storage. So just having one flip-flop wouldn't be possible. We have to have a combination of them and try and make them have more capacity to retain more information. Okay. Shift registers consists of an arrangement of flip-flops. Okay. So each stage flip-flop in a shift register represents 1 bit of storage capacity. Okay. So every flip-flop in a shift register represents 1 bit of storage capacity. The shifting capacity permits the movement of data from stage to stage within the register or in or out of the register upon application of clock pulses, right? So that's the operation of your shift register. So as and when there are clock pulses, okay, so you can see that due to the clock pulses, you can actually move data. Okay, the shifting operation will happen from one point to another. Okay, right. So not only data keeping, or not only data storage, but movement of data is also needed. See, if you can imagine a microprocessor or a microcontroller, it should deal with lot of data, right? It should take data from one point to another point. It should compute things, right? There are a lot of applications um, which is with a microprocessor or a microcontroller, right? It's not that it is used only for addition. It's not that it's used only for subtraction. But then there is a whole lot of other things, that is capable of. So all that is enabling, okay, all that is enabled because of the movement of data from one point to another point. So that's the second point. You see, that's the second point, which actually helps us attain that functionality. The basic difference between a register and a counter is that a register has no specified sequence of states, but in counter, do we have a sequence of states, students? Do we have a sequence of
Yes, sir.
states? Yes, right. So, for example, if I say, with a state table or a state diagram, it goes from one state to another state, right? So, in this scenario, what happens? We know that what is the previous state. We know what is the next state. So, it's a sequence. But here with register, the sequence cannot be maintained, or there's no sequence at all, right? It's just that, it maintains a data. It just stores data. Okay, fine. A register is used for sorting and shifting data. So that is the prime functionality of a register. So the first one that we'll be looking into is serial in, serial out shift register. If possible, you can just make note of this diagram wherein how data is entering and moving from one block to another block. So finally, I get my output, right? So this is your serial in, serial out shift register. It can accept data serially. Serially means what? Just one after the other, just one after the other, and produces the sorted information on its output in a serial form. So output is also coming serially. Input is also serial, output is also serial. Any doubts here? So now we will look deep into serial in, serial out shift registers. Okay. So I have 1, 2, 3, 4. So I can call it as a 4-bit shift, 4-bit register. So because it's capable of having 1, 2, 3, 4, 4 bits. It needs 4 clock pulses to store 4 bits. Okay. Why do you think it needs 4 clock pulses? Why can't I do it in just 1 clock pulse?
So because it's moving one after the other.
Correct. It's moving one after the other. So because of which, what is going to happen? I cannot uh, send data in parallel mode. Okay. So data is just going bit after bit. So after 4 clock pulses, it can reach the final flip-flop. So after first clock pulse, it reaches here. After the first one, second clock pulse, it reaches here. Third, it reaches here. 4, it reaches to the final point. Okay, so which means how many clocks do I need? I need 4 clock pulses to store 4 bits of data. So by the time your data here, the input comes to your output, I need 4 clock pulses. Okay, fine. So we'll be seeing a waveform 1010 and how it gets inside the register one after the other. We will just look into it. Okay. So any doubts here in this diagram and the concepts that I've explained?
No, sir.
Okay. So have a look at this example and you will be able to understand. This is the same diagram which was there previously. This diagram, the same diagram. Flip-flop 0, 1, 2, 3, 4. 1, 2, 3, 4. So they have given an extra flip-flop actually. Fine. So because it's a 5-bit shift register. Show the states of 5-bit shift register for the specified data input and clock waveforms. The registered the register is initially cleared. This should be registered. Okay. Sorry about it. It's not registered. It should be the register. The register is initially cleared. So what is the data that we are giving here? 11010. So we will see now how this data gets passed from one point to another point. So if you can see this, okay, what kind of clock is this? Rising edge, falling edge, positive edge, negative edge?
Rising edge.
Rising edge, right? Because changes are reflecting at the positive end of the clock. Okay. So my data here is 1 and clock is high. So which means this will be high till the next clock pulse. Till the next clock pulse. So here also at this point of time the data is high. So it will remain high till the next clock pulse. During the next clock pulse, the value is 0. So that 0 will come and sit here. The value changes from high to low till the next clock pulse. In the next clock pulse, the value is 1. So the waveform changes from low to high till the next positive clock pulse. Then the last data is 0. 0 will be there after the positive edge of the clock. Okay. So I think now Q0 you were able to understand. So Q1 will be a shifted version, shifted by 1 clock. Whatever data that you see here, so this is for 2 clock pulses. Okay, let me just name them. Let's put it as A and B. So here this A and B is appearing here. So it is shifted by 1 clock pulse. Okay, so the whole cycle. So this, so instead of this starting here, but after the next clock pulse, you can see that the data is getting shifted. Okay. So finally, I will be getting a 0. Sorry, 1. First I got a 0. So 0 will be here. And at the next instant of time, 1 should appear here. In the next instant of time, only 0 will appear. 1 will appear. And then only 1 is transferred to Q4. So if you can read data, So we have given 11010. So you have to read data in this fashion. 11010, because Q4 is your MSB and Q0 is your LSB. This is your most significant bit. This is your least significant bit. That's what you're seeing here. Okay. So I have 1, 0, 1, 0. This is the data. This is the data. So ultimately your Q0 will have 0 after 4 clock cycles. Is there any doubt in this waveform and how this shift register is functioning? Please ask me. Is the concept clear?
Yes, sir.
Yes, sir.
Fine. So we are looking at the data here. Okay. So whatever data is there, that is appearing only after the positive edge of the clock. Positive edge of the clock. Okay. Right. Now, see the first pulse. So the first pulse that we have here will be only concentrating on Q0. So which means, so for the data to pass to Q1, we need 2 clock pulses, right? So this 0 will continue to be 0. This 0 will be continued to be 0 till the next clock pulse, till the next clock pulse. After the next clock pulse, whatever was here in Q0, that comes down here. 1, 1. So this 1 and 1 is here. The next 1 and 1 will be here. So I hope you're able to follow, right? What I'm trying to say, isn't it? Yes, are you all able to follow as to what I have
Sir.
written? Yeah.
Yes, sir.
Okay. So data gets passed from one point to another point only after the clock pulse. So that's an important concept which you all have to remember. So the next one now, serial in, parallel out. Data bits enter serially. Once the data bits are stored, okay, once all the bits are available here, means after 4 clock pulses, in this case 1, 2, 3, 4, after 4 clock pulses, then I will extract the data. So that becomes a parallel out. So serially it's getting in, but parallelly we can obtain the data. right? So this is an example of a 4-bit register, serial in, parallel out. So we use D flip-flop for this when data is entering through the data input, and each has its own clock, but commonly connected clock. Okay. So here I will get Q0, Q1, Q2, Q3. So this is a representation of serial in, parallel out. Take this as an example. Okay. And we can show that how data is transferred from one point to another point. Now, can you take this question and start working and tell me how, or you can work out and just verify if the waveforms are proper or not. Take down the question. So if I give you a question like this, you should be able to take data, any data, any 4-bit data, and you should be able to show in the form of waveforms and clock. So here, for example, I am just taking 0, 1, 1, 0. Clock is taken high, low, high, low, high, low, high, low. So all the clock pulses are taken. At every positive edge of the clock, I make my markings. So 0 would appear at Q0. And then for my next 1, 1, this is 0. So shifted by 1 clock pulse. Okay. Shift the data by 1 clock pulse. So you will be able to see that the 0 is getting extended till the next positive half of the positive cycle of the clock. Okay. So Q0, immediately the data is getting reflected here. Okay. But here you can see that it is shifted. So these data, okay, that you see here will be available at all the points after 4 clock cycles. Okay. So that's why I have 1, 2, 3, 4 clock cycles, right? So which means my Q3 will have only 0, and then my Q2 will have 0, sorry, 1, 0, 1. Okay. Then Q1 also will have a data. At the end, I have 0, 1, 1, 0. Right? So you can just make a note here. This is 0, 1, 1, 0. Is this data matching with our input here? Yes.
Yes, sir.
Okay. So this is how you can actually think of serial data and parallel output. So I can ask you questions. I can tell you to plot a waveform. So you can use this as an example. Okay. So in our upcoming lectures, we will be still looking into few more concepts. Okay, which is like serial in and parallel out. And we will also discuss the general diagram parallel in, serial out. Okay, and the different circuitry which is used for 4-bit parallel in, serial out. Okay, so I hope you all have understood concepts that I've explained so far. So do you think these waveforms are helpful for you to understand whatever was explained? Are you able to figure out as to how this data is passing from one point to another? Isn't it? Are you all able to understand the concept? Okay.